Okay. Well, I hope everybody's having a good day. A couple of big items. Okay. Remember, tomorrow is your test. Okay, let's definitely go ahead and make sure to get those phones off the desks, please. Make sure to put those up, earphones out. There we go. But your test is tomorrow. It will cover frequency tables, frequency histograms, box and whisker plots, cumulative frequency, measures of central tendency, all that good stuff. So hopefully you're looking at your resources the past few days, getting ready for that. You still have one more morning. I'm here at 7:45. If you have any last minute questions or kind of confused about something, the papers you picked up on the way in, that was the original version of the frequency and box and whisker plot quiz that I was going to give, but I ultimately decided to go in a different direction. So just thought I'd go ahead and let you take a look at those. They're extra resources, extra problems, if you'd like to take a look at them, okay, for preparation for tomorrow. Focus activities, this is the last one of this set. They are officially due on Friday, but if you want to go ahead and turn them in at the end of class, please feel free to do so. A lot of people are doing so today. Next week, as we continue with our lessons, we'll go ahead and continue with the focus activities, so you'll get number 4 next week. Okay, number 4 next week, and then however many we're able to get, by the end of the 6 weeks. Okay, so I think that's everything I have, unless anybody has any questions. All right, well, let's go ahead and take a look at our focus activity. This one's talking about, well, what does that little notation right there mean when you have a power of -1? Inverse. Okay, and I kind of described that as a power of -1. And when you were taught this in algebra 2, it was really, really important. We made sure that you understood it wasn't a power, but I didn't have any other way really to describe that. Okay, so we have f of x is equal to the square root of x minus 5, and we have this interval here defined for its domain. X is greater than or equal to 5. And that makes sense because what's going to happen if I go with something smaller? Like, what if I try to plug in 4? There you go. What happens when you take the square root of a negative number? It becomes imaginary. Okay, so it doesn't have a place in the real world, which means it's not part of our graph. So we're going to go ahead and take a look at that. So the first thing, A, it just says, okay, find the inverse evaluated at 2. All right. So one of the things, the problem really doesn't ask for this, but I'm going to go ahead and have us do it anyway because it brings up a concept that you probably haven't seen for a while, since way back in Algebra 2. Let's go ahead. We already have the domain for this guy. What would his range be? And if it helps, maybe I could go ahead and sketch it. What does the radical parent look like to begin with? There we go. Some people are motioning with their fingers in the air. So it's half a parabola, right? So something like this. That's going to be the square root of x. Well, think back to your transformations. What would that minus 5 do to it? Move it to the right? Okay, a couple people said that, but wait a minute. It says minus. Why would it move it to the right? There you go. The x's, any kind of transformation done horizontally, was always going to be way trickier than the y values. So if it is subtracting or adding from x, you're going to take the opposite. So we're just going to shift this guy over. Let's say this is 5 right here. So there we go. That would be the square root of x minus 5. Okay. Well, looking at that, maybe it's a lot easier for people to go ahead and tell, well, what is the associated range we have here? What are all the y values? Okay, from 0 to infinity. So I'm going to go ahead and rewrite this. Remember, in interval notation, that's using the brackets and the parentheses. So the domain for this guy is going to be everything from 5 to infinity, while his range is going to be everything from 0 to infinity, right? Now, the reason I go ahead and bring this up is because when we're dealing with inverses, particularly inverses of functions, what are we doing with the x's and the y's? You're switching them. Okay, all the elements in the domain, all the elements in the range, they switch places. The x's become the y's and vice versa. So if I want to find the inverse of this guy, the square root of x minus 5, does anybody remember how I do that?
And then you're going to solve for x.
Okay, so she said y equals square root of x minus 5. Okay, Now, actually, some people do go ahead and do that. I do it slightly different. Before you go ahead and solve, you switch the positions of x and y in the function. Okay, so instead of y equals the square root of x minus 5, I'm going to say x equals the square root of y minus 5. And that makes sense because we just talked about you actually switch those elements in the domain and the range. Okay, now we solve for y. The result should be the inverse function. Okay, so how will I go ahead and get y out from under this radical? Square it. So I'm going to go ahead square the left, square the right. See, those are going to cancel because they are inverses of each other. So x squared equals y minus 5. What do I end up with for my inverse? Okay, so x squared plus 5 is equal to y. And this is one thing that I taught my students, in the previous years, both in Algebra 2 and especially when we're in pre-calculus, that once you take a look at this, okay, would x squared plus 5 be a function? Do you guys remember what I'm talking about when I say function? That means it passes what test? The vertical line test. Basically, if I were to look at a graph of him, would any values of x repeat? Okay, no. So now, because that inverse is going to be a function, I can go ahead and use the correct notation. So I can only use that inverse notation if the resulting inverse is a function. Okay. But I want to go ahead and kind of just, emphasize some ideas here. This guy would be restricted. If you were to graph him, you wouldn't see the entire graph. You wouldn't see the entire parabola. Does anybody remember why? Think about it in simplest terms. You started with half a parabola, right? Okay, it was a sideways one, but square root of x minus 5. So when I go ahead and reflect it across y equals x, okay, if I invert it, take the inverse, I should still have what? Half a parabola. Okay, so what would the domain of this inverse be? Remember, what did we say at the beginning you do with the x's and the y's? You switch them. So the domain of the original function becomes the range of the inverse. Okay, the range of the original becomes the domain of the inverse. So this would be from 0 to infinity, and the range would be everything from 5 to infinity. Okay, and that's going to result in half a parabola. Does anybody want me to graph that again to show you that? Is this kind of coming back to you folks? Kind of? Good? Okay. All right. Now, like I said, we didn't need to go through all that. It wasn't absolutely necessary, but I figured, we're bringing this up, and we really don't have inverses as part of our curriculum here in IB, so I figured why not? Okay. It's fun. So now I want f inverse of 2. So now we're to the easy part. Well, what do I do when I have function notation? What does this want me to do? Yeah, whatever value you're provided, you're simply going to plug it in for x. Now, I ended up with x squared plus 5, so I'm going to go ahead and say 2 squared plus 5, so this is going to give me 9. Okay, so the value for part A should be 9. All right. Now let's take a look at B. Okay, let me go ahead and erase all this, give myself a little bit of room here. So we found this to be 9. Okay, B, let G be a function such that G inverse exists for all real numbers. Given that G of 30 equals 3, find, now this right here, that's not an O, that's another notation for composition. In fact, instead of using the little circle right here, you could actually do this. You could say F composed with G inverse of 3. Do you remember composition of functions like that? You may have seen it more in that form than actually using that little circle. Okay. How do I evaluate one of these? Would I go with F or G inverse first? G inverse. Remember, I always start with the innermost function and I work my way out. Okay, so it's going to be easy to do. I mean, we already have function F right here, but can anybody help me out? What's going to be G inverse of 3? Think about the key idea. Moving from a function to its inverse, what do we do with the x's and the y's? We switch them, right? So think about what they're giving me here. They're telling you that for function g, g of 30 is equal to 3. So an ordered pair located on that graph, whatever he may be, wouldn't it just be 30, comma 3? The input is the x, the output is the y, right? And remember, we just said, what do they do with the inverses? They switch the x and the y. Remember, the inverse is going to undo any operation that the original function has done. If the original function multiplies and adds, well, then the inverse should be doing what? Dividing and subtracting. It's using the opposite operations. Okay, so if I'm thinking about G inverse, do I have a point I could switch around? Yeah. What would be the input for G inverse? 3, and it should give me 30. Because this point on the inverse should simply switch. Is everybody okay with that? Any questions? Well, now that we know that, what's G inverse of 3? 30. So I'm going to replace this with 30. So I still have f of 30. Remember, when you're dealing with compositions, the output for the inside function becomes the input for the outside function. Say that 3 times fast. Okay. Basically, the answer for the innermost function becomes the next input for the next function. The answer I got of 30, I'm just now going to plug this directly into f. Okay. So let's see here. F was just the square root of x minus 5. So the square root of 30 minus 5. What should my final answer be? 5. Who said that was easy? Cool. I like that. Hello. Hey, all done? All right. How many people had that completely done before we started? How many people at least had A done? Successful. There's a lot of hands going up there. Okay, good. Okay. Excellent. All right. Any questions? All right, so there's only 3 focus activities in this first set. Due Friday, but we'll take care of this at the end if you want to turn them in today. All right, and I believe there should still be over here by the broken pencil sharpener some extra copies of numbers 1 and 2 if you happen to have misplaced them, lost them, whatever the case is. Okay, so before we move on to standard deviation, let's see here. Did we have any questions on the assignment? Any questions on cumulative frequency that you would like to ask?
So, why sometimes whenever we were graphing things, would we use the midpoint and other times we would use the frequency?
Well, now the cumulative frequency is used to create percentiles. That means I can find a certain element in the set that allows me to say, okay, if they're all in order, everything at or below that represents a certain percentage. Okay. Now, here, what we're talking about with cumulative frequency, because we don't know what the data is. Like, for example, this is talking about temperatures during the ski season in Aspen, okay, for whatever time period this is. So, for example, I know that there are 7 temperatures that belong in this class interval right here. But the problem is I don't know what they are. So if my data is not actually provided to me, it's already been broken up into class intervals. If I'm wanting to find the mean, then I need to use the midpoint when doing so. Okay, because it's really our best bet, because these values, I mean, they could be anywhere. Okay, I could have 16.6, or I could even have all the way up to 21, and maybe even some of those temperatures would repeat. All I know is that there are 7 values between 16.5 and 21.5. So our best way of getting the mean, okay, our best approximation, is to use the midpoint. Okay, so basically for each one of these, you found that all you needed to do was take the lower value and add what? How far is it from 16.5 to 21.5? Okay, 5, so you just need to add 2.5. Okay. So in fact, what would be the first midpoint? 19. And then it really just depends on the strategy. Now when we're talking about cumulative frequency, if you're going to go ahead and sketch it, okay, you have to go ahead and create your ordered pairs using the upper boundary. That's basically your x value, the horizontal. What's the vertical?
Cumulative.
That is the cumulative frequency. Okay. Cumulative frequency. Okay. So really, cumulative frequency, the best way it's used is to figure out certain percentiles for specific elements in your set. I don't know. I kind of went on for a little bit there. Did that answer your question? Okay. All right. Was there anything else on the homework that we wanted to talk about? Hello?
Is Ella here?
Yes.
Can I see her?
Oh, okay. All right. Any other questions? You're very welcome.
Can we just go over C to make sure I got it?
Just go over C. What was C? Okay, find 32 degrees on the horizontal axis. What's the cumulative frequency of number of days with high temperatures less than 32? Okay, so in order to answer this question, we need to go ahead and create the graph, which means I need to complete what? Yeah, the table, right? So let's go back to the table, okay? Because I know that I've already got half of the ordered pairs that I'm going to be plotting. Okay, I know these right here are basically going to be my x's. The cumulative frequency, that's going to be my y values. So walk me through this. How do I find the cumulative frequency? What do I start with? Joey? There you go. Start with the very first frequency value you have. Okay, so I'm going to go ahead and put the 7 here. But then what do I do with that? Okay, and then we just continually add the frequencies for the other intervals in order as we go. So 7 plus 13 will give me 20, plus 20, 40, plus 26, 66, and then now we get to 98, and then we just continue that all the way through. So in fact, 132, 151, 164, 167, 173, and then 179. Okay. There we go. And the very last row of your cumulative frequency, like that 179, what does that represent? Yeah, that's the total number of elements in your set. So I know that this encompasses 179 different temperatures. Okay. And where are we? Aspen? Okay. Now, for the next one, I don't think we need the midpoints. We have everything we need to go ahead and plot these. So you'll notice what I did. I already went ahead and showed you the scale that I used here. Horizontally, I used every line as 2. So I was able to get all the way up to 70. And then I had to get a little creative on the vertical. Every second line, I counted that by 15. And I was able to get all the way up to 180. So you have to decide, you know, what's the best way to go ahead and put your values down to encompass everything you have. All right, well, this is probably going to take me a minute or two because I now got to plot these points. So, for example, 21.5 is going to give me 7. Okay, so 21.5 would probably be right about here, and then I'd say right about there. Okay, and is everybody okay where I got that first ordered pair? Okay, going back over here, all right, that's the first upper class value against the first cumulative frequency value. So 21.57. And then I just have to do that all the way down for the rest of those points. Okay. So kind of bear with me for just a second. Okay. You'll see there is a point to this. Yeah, let me go back. Okay. 26.5. So let's see here. 22, 24, 26.5. So probably right about there. And then I want to go up to 20. Okay, so maybe a little short right here, right about there. And, you know, these are not exact, especially because of the way I went ahead and labeled my axes. So we're going to be really close. 31.5 would be 40. Okay, so 31.5 would be right about there. That would be at 37, so maybe right about here. Okay. And then we got 36.5, 66. 36.5 would be right about there, and then 66, maybe right about there. Okay. 41.5, 98. Okay, 41.5, 98. Okay, would be just above that line right there. Maybe right about there. Okay. 46.5, 132. 46.5, and now 132. So that'd be 127, so maybe about right there. Okay. I think we would all agree this is the exciting part of the lesson. Oh, woohoo. Ooh, don't get too excited now. Okay. 51.5 would be right about there. 151. Okay. There we go. Maybe right about there. We're almost there. 56.5, 246.5. So let's start right about here, going up to 164. Is that on the line right there? Okay, so close. Hey. And then we have 61.5, 167. Okay, so 246, 66.5, and then 167. So make sure to be right about, maybe right there. Okay, that's the marker made. And then 71.5, 179. 71.5, and then 179 would be right below that. So probably something like that. Okay. Is that about what everybody was getting on their paper? Okay. All right. Well, let me go ahead and draw this line now. Okay. So my cumulative frequency curve goes a little up at the end from where I had it originally. Did I go off on that? Oh, well. Not popular today. Hello. Hey. Okay. Radley. Okay, there you go. All right, so let's see. C, find 32 degrees on the horizontal scale. What's the cumulative frequency of number of days with high temperatures less than 32? Okay, so this is what we were talking about just a moment ago when Ella had her question. Okay, so let's say 32 is right here. Okay, would everybody agree? Now, I'm going to go straight up to my graph, and as soon as I hit it, what am I going to do? I'm going to go straight over here. Now, because this is a cumulative frequency graph, I would say maybe that's hitting right about 44. But remember, what is the vertical axis representing? The number of days, the number of days. Okay, so the question says, what's the cumulative frequency of number of days with high temperatures less than 32? Well, according to the graph, because I was able to locate this, I would say that there were roughly 44 days that had 32 degrees or less. Okay, so I'd say about 44 degrees. Now let's say, what did I get originally on here? Oh, I actually got 44 as well. Good. Now, let's say you, maybe on a test or something, if you have to go ahead and create a cumulative frequency curve, maybe one coming up tomorrow, you know, if you were to get something like maybe 43, 42, what's going to happen? Would that be acceptable? Okay, I heard a no and I heard a yes. Yeah, I do have to say, if you're not going to get the answer I get, I'm going to count it wrong. You know, I'm kidding, right? Okay, so like on a problem like this, I would probably go ahead and give you a leeway, maybe 42 to 46. Okay, a nice little leeway. I don't want to make the leeway too large because I want your graph to be, you know, somewhat correct. That makes sense? Okay, so I think, you know, whatever interval I give you should give you enough room if your graph is slightly off. Okay, who? What?
The joke about leeway like 3 times now, which makes me think that you're not kidding about it.
Oh, I'm kidding. I'm kidding. I'm rubbing off on Joey. There we go. There we go. If all the students start making jokes, then I've done my job. Okay. All right. Who originally asked me? This problem is taking a while. Okay. So.
Sorry.
Oh no. That's good. I mean, does it make sense?
No, I just wanted to make sure I got it.
Oh, you just want to make sure you got it right.
Yeah.
Oh, did you get it right?
Yeah.
Nice. Now, what'd you get? Did you get 44 or did you get
45.
45? There we go. So that'd be perfect. Okay. How many people, other people who constructed the graph got really close to 44? Okay, that's good. That's good. That's a lot of hands going up. Okay. Nice. Okay. Now, Ella, if we were talking about percentiles, do you want me to kind of change this problem to kind of give you an example for that, or do you feel okay now? Huh.
I think I'm okay.
You think you're okay?
Yeah.
All right. Was there anything else on the homework? That was a good question. Okay, that was a good question. So I want to make sure I answer it. Yes, ma'am. Cortland.
So say you get like 89%, like if we're talking about test scores,
Uh-huh.
that means you scored 89% higher. No, you're like
No, 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 no. Yeah, what that means is that like that one problem, I think it's number 3 on the back that's talking about that. Okay. Let's see here. Yeah, or no, where is it? Number 2. Okay. You took the English achievement test to obtain college credit in freshman English by examination. If your score was in the 89th percentile, what percentage of scores is at or below yours? Well, it would be 89%. Okay. What we're saying is that no matter what all the scores were for this particular class, if I were to order them from the smallest all the way to the largest, okay, so let's say, we have some small scores down here, 10, 15, dot, 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 and then we have, oh, I don't know, 70, 81, 93, 100, 100. And that's also another good thing to bring up. Is it possible that some of the data could repeat? Like, especially if you're taking data from grades, could some people get the same grade? Very possible. So what we're saying is, if your score is said to be at the 89% and you got a 93 on yours, all this is telling you is that if you order your data from smallest to largest, from your score down, that would represent 89% of all the scores that were taken. Okay. Does that kind of help to clarify that? Okay. So like on here, if I were to go back, and I'll just go ahead and do one because Ella brought up the question. Let's say I wanted to know what temperature represented the 50th percentile. Okay. So I want to take 50%, but 50% of what? Remember, how many days did they record this data? What kind of, well, 179. But let's just go ahead and say 180 to make it easier. What's half of 180? Okay, 90, right? So I'm going to go ahead and locate 90 on this graph. Okay, I'm going to go straight across. As soon as I hit it, I'm going to go down. So it looks to me like I'm hitting about what? 40 degrees. Okay, so again, by the same idea, if I knew all of these temperatures, all 179 of them, if I went ahead and put them in order from the smallest all the way to the highest temperature, okay, then the median, the 50th percentile, should be right about 40, so everything less than that should represent 50% of the data. Okay, is this helping to make a little more sense? Is anybody confused? Okay. And this is good. I mean, we're almost done with our class period, so it is true. Time flies when you're having fun. Okay. But if you have questions, I mean, this is good. Definitely ask them. All right. Good, good, good. Anything else? Yo. Okay.
What is so the y-axis is the cumulative frequency?
That's your cumulative frequency, yes.
You're going to take your percentile.
That's basically the number of elements in your set.
Okay. So you're going to take your percentile
from the number of elements, yes. Mm-hmm. And in fact, there's another way to check that. Let's say, we're looking for the 50th percentile. Let's see if we actually got pretty close, if my graph is pretty accurate. I can come back over here to the table. I showed you this trick the other day, right? Let's see if this will work now. We wanted the 50th percentile. So remember, we just said half of 180 was what? 90. So basically I'm looking for the median, the middle value if I go ahead and line them all up from lowest to highest. We'll start with this. Okay, so 7, way too low for 90. Plus 20, plus 40, plus 66. But by 98, you'll notice I can't go any further because remember, I'm looking for the 90th term. That would represent half of the data. Okay, so it would fall right here. And remember, what did I get on my graph? I got 40. Okay, so that kind of tells me that my graph is fairly accurate. It's probably not 100%, but it's reasonable. Okay. Is everybody all right with that? Okay. Good, 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 good. All right, nice. That was a lot of good questions. Okay, well now I did want to go ahead and continue with standard deviation. We're really only going to be able to do one thing, and then most likely we'll continue this on Friday. Okay, so I wanted to show you one thing. Here, nope, not that. Here we go, right here. Because on your paper exams, and I'm even going to do this occasionally on your exams, like maybe the one tomorrow, okay, we know how to find mean, median, and mode, for example, right? Okay, how do you find the mean of a set of data? Yeah, you add them all up, you divide by the number of elements you have, okay? But for IB, it's not always going to be just that straightforward. Okay, they're going to want to see, do you actually know about the concept to which you're being asked? All right, so for example, it's not unreasonable to see a question like this, okay, where knowing how to take the average is going to help you solve the problem. And this applies to so many different topics, okay? So that's kind of the good news and the bad news. This one says, I wanted to go ahead and show you this prior to the test tomorrow, just to kind of, give you a heads up. But it says find X if 1, 2, 4, 5, 8, 10, 11, and X have a mean of 7. Okay, so see, I already know what the mean is, but I got to find that missing element. How would I do this? Now, think big picture. You told me how do I find the average normally? Okay, I take the sum of all my terms and then do what? Divide it by the number that I have. Okay, well, let's start with what we know. I have 1, 2, 3, 4, 5, 6, 7, 8 terms, right? So I'm going to be dividing by 8. Now, I already know that whatever I'm dividing by 8 has got to give me 7. I already know what the average is. What's going to go in the numerator? There you go. See, I don't know X, but I have to take the sum of all of them. So I'm going to go ahead and say X plus. Will somebody help me out? 41. Very good. Who said it? Thank you. Thank you very much, Reese. 41. Okay. But you see how I use the idea to kind of work backwards and create an equation? And that's what they're going to do a lot of times. They won't be very straightforward and just say, okay, use this formula on this set of data. They're going to want you to really think about what you're doing. Okay. That's what makes some of the paper exams kind of difficult. Well, where would I go from here? There you go. Okay. I'd go ahead and multiply through by the denominator. So those 8s are going to cancel. That gives me X plus 41 is equal to 56. Subtract the 41. What's the missing element? 15. Okay. Is everybody okay with that? All right. Well, good, 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 good. Okay, well, very quickly, I'm going to go ahead and get you started on something, and then we won't be able to finish it for a couple of days until I see you on Friday, because tomorrow is the test day. But standard deviation. Someone describe to me what that means. What were we talking about yesterday? Okay, what's that, Jalen? How spread out the data is. That's exactly right. It's a descriptor. It's a measure of spread. Okay, it's a numerical value. The higher the number, the more spread out the elements in your set will be. The smaller the standard deviation, the closer those elements should be to each other. That is exactly right. Now, I walked you through the process. Here's the formula that I mentioned briefly yesterday. You want to go ahead and take the sum of the squared differences between each element in the set and the mean. And then you want to go ahead and divide it by n, which is the total number of terms that you have, right? So we finished up yesterday. We did this example right here. Let me go ahead and get you started on this one. Okay. Now, what if we had a frequency table, but I still wanted to go ahead and figure out what the standard deviation was for it? Okay. Now, remember, you could go ahead and list this whole thing out. Like, for example, it says there's a score of 11, and then it says frequency 3. What is that actually telling me? What's that, Ellen? There you go. So if I did want to generate the set, I could say, okay, well, it should be 11, 11, 11. How many 12s? 12, 12, 12, 12. And then you could go all the way through, and by the time you finish, you should have written out 50 items. Remember, that's what the frequency is telling me, the number of times that element appears in your set. Okay. Well, again, I think a table is a great way to do this, and it's progressive. Okay. Because what I need to go ahead and do is first find the average. Okay. But in order to find the average, I need to go ahead and take the sum of all the elements. So does it make sense why this column here, it's first having me multiply the frequency by the element? When it says X, it's just talking about an element in your set. Because if I were to add 11 plus 11 plus 11, what would I get? 33, which is 11 times 3. Okay. And then 12 plus 12 plus 12 plus 12, well, that's the same as 12 plus 4, which would give me 48. Okay. So we're going to run through this first one together very quickly because we're almost out of time, because I'm going to want you to do something before I see you on Friday. Okay. So somebody help me out. 13 times 5. 65. Okay. 14 times 2. 28. 15 times 8. 120. 16 times 9. What? Little off. 144. Okay. And 17 times 5. 85. 18 times 8. That is another 144. Here, let me rewrite that one. That is 85. There we go. And 19 times 6. 114. Okay. So is everybody okay where we're getting those from? Okay. So somebody give me the grand total of all those products. 781. Perfect. Okay. So I know the grand total is 781. Okay. I'm wanting to find the mean. What am I going to divide by? 50. Why 50? Because there's 50 elements in the set, right? Okay. So somebody help me out. What are we getting when I find that? I'm getting 15.62. Emmy's absolutely right. 15.62. Okay, so now you have everything you need to go ahead and complete the table. Okay, for this next column right here, you're going to take X, the original element, and you're going to subtract the mean that you just found. So for example, okay, 11. Oh, it's not letting me do it. Let me go back over here very quickly. Okay, now let me see if it does that. Okay, so 11 minus 15.62. Okay, so that's going to give me negative 4.62. Okay, so I'm going to come on over here. Oh, I'm on the wrong one. So that's negative 4.62. So you're going to do that for all of them. 12 minus 15.62, 13 minus, okay? Because I got to get the differences. Then what am I doing in the next column? I'm going to square that. Okay, so in my calculator, I'm going to go ahead and say parentheses negative 4.62, or you could just go ahead and use the square button from the previous answer. So I got 21.3444. Hello. Hey. So I got 21.3444. Okay. And then now, what's it going to have me do here? There you go. We're going to take those square differences, and I'm going to multiply it by the frequency. Because remember, we have to do this for every one of the 50 elements. And how many times did 11 show up? 3 times. Okay. So I need to multiply this by 3. which gives me 64.0332. 64.0332. Okay, that's one row taken care of. Okay, now what we need to do is the same thing. I want you sometime between now and Friday, finish filling in the table just like we did. Okay, now when you get down here, okay, you're going to take this sum total. What are you going to do with it? You're going to divide it by something. Remember, look at the formula. Okay, so see, you're going to have this sum total right down here. Well, what are you going to divide by? You're going to divide by 50. Now, if you simply take that sum and divide by 50, what do we call that? It starts with a V. That's the variance. How do I get the standard deviation from the variance? You take the square root of that. There you go. Remember, that's the formula. Now, if you want to go ahead and take those extra steps and go ahead and find the standard deviation, please feel free. But please take time. Maybe it's not going to take more than 5 minutes. Get yourself a calculator, run through those rows. Jacob.
Do you want to surround it to a certain decimal point?
You know, because these were like that, I went ahead and left them at 4 decimal places. Okay, so if you do go ahead and round smaller, your answer will be close, but not exact as much. Okay. All right, good. Thank you, guys. It was a great class today. We have less than 2 minutes. If you could get the calculators back to the front, please. Okay, I need those calculators back to the front before I can let you guys go. And don't forget.